Hey guys, welcome back to the next video in our stats series. This one's on mean deviation. What's that all about? Let's take a look. So the mean deviation of a distribution represents the average distance of each value in that distribution from the mean. Now remember, the mean of a distribution is just the average. So what do we care about it? Well, look at the two words. Mean is average and deviation means difference. So how far is each value in a set from the mean? That's what we're talking about here. Now with mean deviation, or how far numbers are away from the average, what we're looking for in a small mean deviation score is that the numbers themselves in the distribution are pretty close to the average, meaning the average represents those values pretty well. But a large mean deviation, where the numbers aren't even close to the average, well, that kind of tells us that while the average is accurate, it doesn't represent the values in the distribution well at all. So here's what I mean in an example. If the mean of a distribution is supposed to represent the average value, we could say that sometimes it's a little bit misleading. Take a look at this example of a couple of values where the average is 75, but it really doesn't represent either of the numbers very well at all. Now let me throw in another example here where the mean again is going to be 75, but the values are way closer to it, showing us that the average, that mean of 75, really does represent the values very accurately. So up on top, student A, two scores, 150, the other 100, has an average of 75, didn't ever get close to a 75 on either score. Student B, though, also an average of 75, is scoring right around 75 every time. So when we calculate mean deviation for student A, we're going to get a large one, meaning it's not very accurate when we look at the mean in terms of how does it represent the numbers in the distribution. Whereas when I calculate it for student B, it's going to be a very small mean deviation, telling me that my numbers are not very far away from that average that I got. Now take a look at these two distributions and see if you can tell which one's going to have a larger mean deviation and which one's going to be smaller. Because one of them is going to be pretty accurate, and the other one, even though the average is the same, it's not going to represent the numbers very well at all. So both distributions have a mean of 82, but in the top one, the numbers are really spread out. In the bottom one, the numbers are really close together, and the mean deviation will tell us exactly what we want to know about how close those numbers are to the mean. So let's look at how we calculate mean deviation. Well, first of all, we have to know the mean of the distribution, and that part's easy because we've already learned that in the last video. So once we have the mean of the distribution, what we need to do is take each value from the distribution and subtract it from the mean. So take a look at how I set that up right here. Now notice when I'm subtracting every value from the mean of the distribution, I'm ignoring any negatives. I'm just writing the difference of that number from the mean itself. I don't care if it's above or below. I just want to know how far away from the mean every value is. So now that I have a list of all my differences as positive numbers only, remember, I don't care if I'm above or below the mean, I just want to know how far away. Once I have the list of those numbers as positive values only, I'm going to take the mean of that new list. So all the differences that I just wrote down, I'm going to add them up and divide by the number of values. Watch how that happens. Now notice I added them up and divided by 8 because I had 8 values in the list. And don't ignore the fact that one of those values was 0, but I still added it anyways, even though that doesn't change the outcome, because it's one of the values in the list, it's one of the differences, and it still counts when I'm dividing by the number of differences. Even if the difference is 0, it's still a valid number in my division. Now I'm going to show you another example of mean deviation. Try and follow along and make sure you understand when I take the differences, I don't care if they're positive or negative, I just want to know how far from the mean. And then when I'm adding them all up and dividing by the total number of values, that's the answer I'm looking for mean deviation.